Greetings. Welcome to the lecture number 5 of Infinite Series lecture series. In our previous lecture, we have learned how to find an infinite series whether it is converges or it is diverges. We have find and learned some tests regarding these two. In that lecture, we will understand a special series that will be very useful in engineering and physics too, and to understand the differential equation to solve the Frobenius method, it will be very helpful for us. Let's start to learn the power series. Let's start. To understand a power series, let's first define it first. This is a power series about x is equal to a. This series is actually a function of this. Look at that series. This series is summation of cn x minus a to the power n is equal to c0 plus c1 x to the power x minus a to the power 1 plus c2 x minus a to the square plus it will be going on to the cn x to the power a minus n. Look at that series. The terms actually also it has a x minus a to the power 0, that is means 1, so it is 1. Look at the terms, this c1 c2 c3, these terms are called the coefficient of this power series, and this a is called center. For example, let's have a series of 0 center, and now what if the all coefficients are 1? Then the series can be written as fx is equal to 1 plus x square plus x cube plus dot 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 x to the power n, that can be written. Now look at that series. Okay, this is the geometric series, and this that will be converged if the value of x will be from -1 to 1, will be converges, that will be converges if the value of x is from -1 to +1. To understand it better, let's have another example, but this time the center should not be 0. Let's have an infinite series that in sum of n from 1 to infinity x minus 3 to the power n by n. To find that whether it is converges or not. How to solve it? We'll solve by using D'Alembert ratio test. If you don't have any idea what is D'Alembert ratio test, we have made another lecture on this. Click the I button and go through this. Let's the D'Alembert ratio test says us that it should be un plus 1 by un sum of, this would be look like this structure, that x to the power minus 3 by n plus 1 by n plus 1, and the denominator will be x minus 3 to the power n by n. Now this, if we simplify this, that will be x minus 3 into n by n plus 1. Now if we again divide it by this n by n, then we will have that x minus 3 into 1 by 1 plus 1 by n. Now look on things. If that n tends to infinity, if n tends to infinity, these terms will be x minus 3, because that 1 by n terms will be 0, so it will become the mod of x minus 3 will be less than 1, and to fulfill that condition, the at x should be from 2 to 4. For this is the condition of this, for 2 to 4 region it will be convergence, and for other rest of the other, for every other number of x it will be divergence. Thank you.